Now let's take a look at question number 24 from exercise set 5.2. And in this question we are given two observing stations A and B that are 10 miles apart, and they are observing a weather balloon due west. Let's label it anything. We can label it W. You can label it anything you want. I'm just labeling it W. And this one, okay, so what else is given here? We are given that the angle of elevation from this station is 17.6 degrees. Now if I extend the horizontal from A, we get the angle of elevation, this is given to be 78.2 degrees. Now let's complete the triangle, and we can do that by dropping a perpendicular down to the horizontal. So it should look like a right triangle there. Let's make it a right triangle with right angle at, say, C. So we now have this situation. We know that A and B are two stations 10 miles apart. We want to find how high the balloon is from the ground level, but we don't know the distance CA, so let's say that's X. Now let's consider the smaller triangle first, which is triangle WCA. In this triangle we don't know H, we don't know X, but we know the angle is 78.2. So using SOHCAHTOA we can write tan 78.2 is opposite over adjacent, which is H over X, or if I cross multiply I get H equals X tan 78.2 degrees. So let's leave this triangle up to this equation, and let's go back and look at the bigger triangle now, bigger right triangle, which is WCB. Again, we are going to use tan of B, or tan 17.6, where this distance CB is X plus 10. The adjacent distance is X plus 10. So we get tan 17.6 degrees equals H over X plus 10. Now if I put tan 17.6 over 1 and cross multiply, and I put it over 1 just to show the cross multiplication, but you don't have to if you're comfortable doing it without it. So after cross multiplication you get X plus 10 tan 17.6 equals 1 times H is H. So now see that both the equations are giving us a value for H. H equals X tan 78.2, H equals X plus 10 tan 17.6. But since we're talking about the same H, that means these values must be equal. So one way to solve from here onwards is by equating the equations. So we can say that X plus 10 tan 17.6 is equal to X tan 78.2. So let me write this down first. Okay, so now let's use the distributive law to distribute tan 17.6 in the brackets. So we get X tan 17.6 plus 10 tan 17.6 equals X tan 78.2 degrees. And now we know that if we want to solve for x, we have to bring the terms containing x together. So these two terms should be on one side. So we will subtract x tan 17.6 from both sides. So, or in other terms, we are moving x tan 17.6 towards the right hand side of the equation. So we get 17.6x equals x tan 78.2 minus x tan 17.6. So it should be x Okay, now we know that we will have to factor out x from here. It's kind of like collecting like terms, or just factoring the x out so we can do the subtraction. Now use your calculators to find the value of tan 78.2 minus tan 17.6. So I'm using mine, and I'll write the answer once I know what it is. So it's 4.4695. Okay, so maybe something is wrong here. Oh, it should not be x tan 17 now. It should be 10 17.6. Excuse me. Now put that in the calculator and find the value of 10 17.6, which comes out to be 3.1722. I'm just rounding it up. So now to find the value of x, you know that we have to divide by the coefficient of x to isolate x. So to find the answer, I have to go 3.1722 divided by 4.4695, which gives me 0.7097. So if we just use the 4 decimal places, it comes out to be 7097. But see, we found the value of x, which is what we really don't need, but we can use it now to find the value of h. Now if we back substitute the value of x in the first equation that we had found, we can find the value of h. So now what we are going to do is we can substitute the value of x there. So h equals 0.7097 times tan 78.2 degrees. Okay, now put that in the calculator. In all these questions, when you're working on it, make sure that your calculator is in degrees mode, so that, you know, sometimes if it's in radian or gradients mode, you get the wrong answer. Anyways, after doing the multiplication, we get it's almost 3.397, almost 3.4 miles. So this is how high the balloon is from the ground. And I hope this makes sense. Even the method that we used in question number 21 can be used here, so you can pick one of the methods that works best for you.